Hello and welcome to our channel, the Cambridge Advanced Level Mathematics channel. In this channel, of course, we try to prepare students for examinations by helping them to solve past examination questions from previous years. And in today's lesson, we brought a question from paper 1 of 2022, and it's question number 2, which reads as follows. The 13th term of an arithmetic progression is 12, and the sum of the first 30 terms is minus 15. Find the sum of the first 50 terms of this series. Now, first of all, of course, we need to discuss a little bit about the idea of an arithmetic progression. Now, supposing we have numbers like this, it's 5, 8, 11, this one doesn't write properly here, 11, 14, 14, and 17. This is a sequence which, if we look at it carefully, it's always such that the number, the two consecutive numbers differ by a constant difference. In this case, if we subtract our 5 from 8, we get 3 there. 11 from 8, 8 from 11, we get 3. 14 from 11 from 14, we get a 3. 14 from 17, we also get a 3. Such a sequence is called an arithmetic progression, and the difference between two consecutive terms is a constant, and it's called a common difference. And the first term of such a sequence is denoted by the symbol A. So the general term of an arithmetic progression is written as A plus, oh my pens are on strike, A plus n minus 1 d, where A, of course, is your first term, your d is the common difference. Now, another one that we can have is 8, 5, 2, minus 1, minus 4, minus 7. This again is an arithmetic progression because 5 minus 8 is equal to minus 3. 2 minus 5 is equal to minus 3. Minus 1 minus 2 is equal to minus 3. Minus 4 minus minus 1 again is equal to minus 3, and so forth. So our minus 3 is a constant which is equal to the common difference. Of course, in this case, the first term is 8. Supposing we want to find a given term. For example, let's say we wanted the 1, 2, 3, 4, the fourth term, let's say. Then we would say, okay, what do we know? We know A. Our A is 8. In this case, there is an 8. Plus, we want the fourth term, so n is 4. So we'll have 4 minus 1, which is 3, multiplied by our common difference, which is minus 3, to give us 8 plus 3 times minus 3, which is 8 minus 9, which is equal to minus 1. Over here, if we wanted the 1, 2, 3, 4, 5, the fifth term, for example, we would have A is 5, plus we want the fifth term, so n is equal to 5, so that gives us n minus 1, which is 4, multiplied by our common difference, is 3. So that gives us 5 plus 4 times 3, which is 5 plus 12, which is equal to 17. So these two are arithmetic progressions. Now, sometimes we want to sum the terms of an arithmetic progression up to a certain number. I'll leave this one there because we can use it. Supposing we want to find the sum to a certain number of our arithmetic progression, how do we do it? The formula is the sum to n terms is equal to n divided by 2. Oh, look at that. N divided by n. Sorry. N divided by 2 multiplied by a plus l, where l is the last term. If we are given that these are the numbers in the series and we need to add them up, we don't have to say 5 plus 8 plus 11 plus 14 plus 17. All we do, because we know it's an arithmetic progression, we just take the last term and the first term, divide by the number of terms, and then divide the answer by 2. So this gives us, in this case, 5. Our 1, 2, 3, 4, 5. So n is equal to 5. 5 over 2, brackets, first term again is 5, plus last term L is 17, to give us 5 plus 17, which is 22. 22 times 5, 22 times 5, I think it's 110. 22 times 5, which is 110. 110 divided by 2, which is equal to 55. So this is the sum of this arithmetic progression up to the 5th term. We can play around with this formula because we know that the last term L is given by this. So instead of L, we can write Sn is equal to n over 2, big bracket, our a there, the first term, and then the last term will be a plus n bracket n minus 1 bracket d, big bracket there. Of course, a plus a is equal to 2a. This then simplifies to, n over 2 big bracket 2a plus n minus 1 d, big bracket. Those are the two formulas which can be used for summing an arithmetic progression. But of course, each one of them depends on what you are given. If you are given the last term and the first term, this is the one to use. But if you are given in terms of information in terms of the common difference and the first term, this is the formula to use. So let's see if we can tackle our problem now, given the knowledge that we have. I'm going to put up the little formulas here so that we don't lose sight of them. This we don't really need. So our first one was Sn is equal to n over 2 brackets a plus l. The other one was Sn is equal to n over 2 big bracket 2a plus n minus 1 multiplied by d, a big bracket like that. So those are the two formulas that we can use. Now let's read again the question. The 13th term of an arithmetic progression is 12, and the sum of the first 30 terms is minus 15. Find the sum of the first 50 terms. The first piece of information that we have is that the 13th term is 12. What is the 13th term? It is a plus n minus 1 d, where n is equal to 13. So it is equal to a, we don't know a, plus 13 minus 1, which is 12, d. We are told this is equal to 12. So let's call this equation number 1. Okay, equation number 1. The second piece of information that we have is the sum of the first 30 terms is minus 15. Which one do we use? We don't know L, we know A and D, So let's use this one. So S30, the first 30 terms, is equal to n over 2. Of course, n is equal to 30, so we might as well write 30 there. N is equal to 30, and 30 over 2 is 15. Let me just make sure you get that. I'm using this formula here. We are told the sum of the first 30 terms is minus 15. So n is 30. So 30 divided by 2 is that 15 there. And this is multiplied by 2a. A we still don't know. Plus n minus 1. Our n is 30. That gives us 29d, which we do not know. Let's call this equation number 2. Right. From equation number 1, we can say A is equal to 12 minus 12d when I take the 12d to the other side. Okay, so I can substitute it in equation 2. I will then have, sorry. We forgot to write this thing here. This is equal to minus 15. That's what we are told. The sum of the first 30 terms is minus 15. So that's what we have here. Now I am going to substitute this for A. So we have S30 is equal to 15, big bracket, 2. Why don't we get rid of the 15 first of all before we do all this? Okay, so this becomes divided throughout by 15. We are left with S30 is equal to 2a plus 29d, which is equal to minus 1, because I have divided right through by 15. Substituting for a, we get this is equal to 2 times 12 is 24, minus 12 times 2d, that gives me minus 24d, plus, of course, this 29d, it's equal to minus 1. Minus 24d plus 29d gives me a 5d. I take the 24 to that side, it becomes a minus 24, so minus 24 minus 1 gives me a minus 25. So d is equal to minus 5. So that's the value of d there. I found d is equal to minus 5. What about my a? My a is given as that. So a will be equal to 12. A is equal to 12 minus 12 times minus 5, which is 12 plus 60, because minus 12 times minus 5 is 60. So it's 12 plus 60, which is equal to, A is equal to 72. That's the value of A there. So my A is equal to 72. Right. We haven't answered the question. They want the sum to the first 50 terms. So now we go back to this. Now that we know A and we know N. So we clear the board. So now S50, the sum to the first 50 terms is equal to now, N is equal to 50. 50 divided by 2 is 25. Big bracket, A is equal to 72 times 2 is 144. Plus, N is 50. 50 minus 1 is 49. D is equal to minus 5. So we put a minus 5 there and we close our bracket. We can simplify that by doing the little calculation inside the bracket. That gives us a 49 times a minus 5, which is minus 245, plus 144. That gives you a 101, a minus 101. So I have a 25 multiplied by a minus 101, which is equal to 25 minus, it's a minus 25, 2,525. That's the sum to the first 50 terms. One might ask, does this work also, this formula? Of course, first of all, now that we know our A and our D, we can find our L and then plug in A and D. Let's see if we can do that. Let's clear, of course, we no longer need this, but we got minus 25. Let's remember that. So let's just put it up somewhere here. Minus 25. That is our sum to the first 50. We want to see if we will be able to get the same number if we use this one here. Of course, our L, we know that our last term is given by that. In fact, our last term, because it's the nth term, which is 50 in this case. So our last term, L, is equal to, our A we have found is 72. 72 plus N is 50. 50 minus 1, that's 49, multiplied by D is minus 5. Let's see what we get there. L is what? So 49 times minus 5, which is that, minus 245, plus 72, which is minus 173. L is minus 173. Let's plug it in there. We have S50 is equal to 50 over 2, which is 25, brackets, A is 72, minus 173 for our L. What does it give us? So it's minus 173 plus 72, minus 173 plus 72. It gives us a minus 101, which is equal to 25 multiplied by a minus 101, again, times 25, which is that we get minus 25. So depending on the information provided, you are free to use this or to use that. They bring you to the same answer. The mark you see over there in green was allocated to the question. I leave you to decide whether this was easy or difficult. Thank you very much.